Welcome to the Manana Ventures YouTube channel. Please like and subscribe. I'm your tutor, Figure Storm. Today we'll be doing functions, specifically hyperbolic and linear functions combined. Now, the hyperbolic function is given in that format, and that's the graph of f, which is there and there. And then g, the linear one, is that line over there. Okay. What is to note is that the graph of g, which is the line, cuts the x-axis at 2 over there, and the y-axis at 2 as well over there. The y-intercept of f is also 2. That's the hyperbola. Its y-intercept is at 2. Right there. Now the first question is determine the value of A, P, and Q. Okay, let's just separate our paper like that. Let's start with question 1 over here. Determine the values of. Now what we have is this graph in this format: A over X minus P plus Q. Right. Now, Q is always the horizontal shift, the asymptote, and the horizontal one, that's a horizontal line, so that's the one. It's at 5. It's the horizontal line. Okay, there it is there, and its crosses at 5. Okay, so Q, can say Q is equals to 5. And then P is the vertical shift on the x-axis. So the vertical one, it passes at minus 1. That means that our P is equal to minus 1. Okay? In completing our equation, we'll have A is equals to A over X. Okay, our P is minus 1, and we have a minus here, so a minus times a minus gives us a positive, so it's plus 1. And then our Q is 5, so plus 5 over there. Okay, so we need to solve for A. We need a point which this passes on, and we were told that the y-intercept of f is 2, which means it's 0. The point is 0, 2. That's our x and that's our y. What we're going to do is simply substitute. Where there's a y, we put a 2, like that. Our a stays over. Where there's a x, we put a 0, plus 1, plus 5. From there, we're just simply getting 2 is equals to A, because A over 1 is still A, plus 5. Therefore, our A is going to be equal to minus 3, because if you take that 5, that side, it changes sign to a negative, and then negative 5 plus 2 gives us a negative 3. Okay. So just out of interest, we've solved our A, Q, and P, but let's put them together. Y, the full equation will be y minus 3 over x plus 1 plus 5. Now, this sign tells us whether it's a negative graph or a positive one. And the negative graph is a hyperbolic negative graph is on the second quadrant and fourth quadrant, which is correct. Right, now let's go to number 2. Write down the domain and range of f. Okay, start with the domain. Now the domain always has to do with the x. Which values of x will it be valid? So we are looking at the hyperbolic graph. So it's valid for all numbers all real numbers, except there's a condition, it cannot be equal to the hyperbole. Okay, so if you look here, it cannot be equal to -1 because it will be undefined. So it cannot be equal to -1. X cannot be equal to -1. And then the range is valid, has to do with the values of y. It's valid for all real numbers of y, except y cannot be equal to 5, where we have our other asymptote. So it cannot be valid for the asymptotes. Okay, now number 3, determine the equation of g in the form y, that's in that form. So number 3, they want it in this form. Y is equals to mx plus c. Now we know that's the y-intercept of that g is 2, and the c there represents the y-intercept. So we have y is equal to mx plus 2. Okay, we just read it off the graph. It's that 2 there. Now we need a point to solve the m. Okay, and we're gonna use that point there, that x-intercept. We were told that it passes the x-axis at 2, so that's the point 2, 0. Okay, so from there, are we gonna do, that's our x and that's our y. Where there's a y, it's 0. M, where there's a x, is 2 plus 2. Okay, therefore our m is gonna be equal to -1, because if you take this 2 to the other side, it's gonna be -2, and then you divide by that 2, get a -1. Then our final equation will be y is equal to minus x plus 2. And that makes sense because this is a decreasing function. If you move from negative infinity to positive, you're moving, you are decreasing. So that is what that's telling us. It's a decreasing function. So it's correct. Okay, our last question is, calculate the points of intersection of f and g. Okay, so f and g. We know that f, they intersect at f is equals to g. Okay, so our f, we solved our f, that's our f there. We solved it to be -3 over x plus 1 plus 5, and g is equals to, we just solved it there, minus x plus 2. Plus 2. Okay, let's just rewrite that in the next page because we've run out of space. So we had f is equals to g, and f was -3 over x plus 1 plus 5 is equals to g. G was minus x plus 2. Yeah, that's correct. All right, now we just need to work this out. So let's take all of this to the other side, and we'll have -3 x plus 1 plus 5. Bring that x to this side, it's going to be plus x. Bring this 2, it's going to be -2 is equals to 0. Then we'll be left with -3 over x plus 1. Now 5 minus 2 is 3. And then that one is just the x, so let's just put the x on its own. 5 minus 2 is going to be plus 3 is equals to 0. Now we're going to get rid of this fraction by multiplying everything by this denominator. So if we multiply that, we're going to have, they'll cancel each other, and we'll be left with minus 3 plus x times that x plus 1 plus that 3 times x plus 1 is equals to 0. So we multiplied everything by x plus 1. It's just that here they cancelled each other, so we're left with minus 3. Minus 3. Now x times x, now we remove the brackets, is x squared. X times 1 is plus x, plus 3 times x is 3x. 3 times 1 is just plus 3. It's equal to 0. Now minus 3 plus 3, they cancel each other. It equals 0. Then I'm left with x squared plus x plus 3x is 4x equal to 0. Now we need to factorize this. We're gonna have x, open bracket, x plus 4 is equal to 0. Now that means that we have x is equal to 0 and x is equals to minus 4. Let's just go back and check. That means the intercept at x is equals to 0 and x is equals to minus 4. Let's check that out. They do intersect at 0. There they intersected, and at minus 4 there they intersected. We can see by also viewing, but they wanted us to calculate, and we have calculated over here. That means we have answered the question. Thank you very much. We are done now.